So welcome back to this channel, students. I hope all of you are doing well. So please type in the chat box, is the audio and video fine to all of you? So everyone out there, so please type in the chat box, is everything fine? Is the audio and video fine? Yes, so please confirm the audio and video. So we shall start very soon. Good evening all of you. Yeah, even I'm happy to see all of you back for mathematics again, okay, because it's been so long. Actually, I think in the past for GATE 2024 we haven't launched a detailed course in English for maths actually, but yeah, now we got the chance. We'll definitely look. So first of all, many of you have asked me, like last year when I was doing XC series, okay, that advanced topics in maths, or when we were talking about fluid mechanics, or basically in technical subjects at few points, many of you have asked me for mathematics course, okay, and we were happy to get this course to you. So after a lot of discussions and meets, finally we were able to meet here for engineering maths again. So first of all, I would like to clear some general questions of mathematics, okay, how the course progresses. Yeah, you can get the notes. I'll just listen to the class for first 5-10 minutes. You'll get answers to all your questions. Good evening all of you. Yeah, nice. Okay, so see here. So first of all, of course, myself Vinay Kumar, okay, I'm going to teach you mathematics for this complete batch, okay. So firstly, the question is this going to be a complete batch of mathematics, or am I going to teach only few topics of maths? Okay, I'm telling you it is full length course, okay. So I'll briefly give you the syllabus after 2-3 slides, so you can actually get 100% of your syllabus from this course, okay. Pakka, you all might have seen me teaching maths in the past, but I'm promising you that we are going to take complete syllabus of maths on this channel for free, okay. Happy? So anyway, let's quickly go on to the things. So first of all, before I know many of you know me, but still I just want to introduce myself. So my name is Vinay Kumar and I'm basically from the mechanical team of PW GATE, and basically how you can, or why you can actually trust me, okay. So basically I have the best ranking of AR4 in GATE examination in the engineering sciences paper, where maths is relatively tough compared to the classical branches, okay. So we have this I have this GATE only rank of 4, and previously I have worked with HPCL and also BRC, Baba Atomic Research Center, which I think recently the current shortlist has come out for the interviews and you guys are preparing. So I have been working with them for past some time. Then I have GATE qualified 8 times in my career, and of course 12 papers, because since 2021 it's been double papers you can answer, means basically you can write for 2 papers. What is XC? I'll tell you, okay. Engineering sciences, I'll just give you a hint, just give me some time. So I've been teaching GATE related things for past 7+ years, okay. So before that I was teaching JEE advanced actually, but in the past 7 years I have moved towards GATE examination. So this 7+ years is regarding my GATE teaching experience actually, okay. And subjects that I teach generally is of course engineering maths, which many of you might have seen. Then fluid mechanics, basically I'm from the mechanical specialized subjects, okay. So I'm going to take here this fluid mechanics, then basic and applied thermodynamics, heat transfer, these other kind of subjects that I generally deal with, okay. And as per current discussion, I'm going to take engineering maths on this platform for now, and it's going to be a complete course. And then what all branches syllabus I'm going to cover? That's the next question. So I'm going to cover the syllabus of mechanical, civil, ECE, TEEE, computer science, IT, XE, and also data science, okay. And of course it's your responsibility to check which part of syllabus is in your branch and to study only that parts. Like for example, in computer science you have only linear algebra, probability and statistics, and basic calculus, okay. It's not advantageous for you to study vector calculus or complex calculus, things like this, okay. So but since I have to cater all your needs, I'll teach the complete syllabus, but it's purely your responsibility to check what part of the syllabus is exactly matching with the content and go for only those set of videos, okay. So now anyway, coming to the story, now recently we have launched a Telegram channel for exclusively English. So whatever the things that's going to happen on this batch are going to be notified on this channel. So all of you can just scan this QR code, it will straight away take you that channel. Just click join. You can join the GATE Wallah English channel, of course, okay. And this is my PW maintained Telegram group actually. So if you click this, you can join my group, where already some 800+, 860+ students are there. So definitely you can just directly get in contact with me, and if you have any queries or something, you can definitely post it in this group. So this group is exclusively for GATE Wallah English channel, and this group is for of course my group actually, which is maintained by the students and me collaboratively, okay. So I'm your previous students. Thank you. Fine. So look here, what is the syllabus? So first of all, I'd like to just give the sequence of the syllabus that I'm going to cover in this batch, okay, so that you all can have a quick follow on how things goes on. So first, initially I would like to start with basic calculus, but because of slight request from students, I have slightly changed the sequence. First, I'm going to cover linear algebra, okay, and when I am covering linear algebra, please don't see matrices as a underrated chapter actually, okay. Maths is linear algebra is one of the very important chapters, and in fact if you see, there is no paper almost in GATE history that there is no question with there is no question in linear algebra. Every paper you take, definitely you'll have some linear algebra questions from that, okay. And the kind of approach we follow, okay, even many of you when you are writing codings and all, you try to work with arrays, okay. So when you are working with arrays, how to write the elements and all, I'll just give you some brief hint, and definitely after finishing of this course, you'll definitely find yourself in a better position in linear algebra, okay. And second, I would like to go is basic calculus, or I would like to call this as single variable calculus. Single variable calculus. And third is the multi-variable calculus. Of course, we'll talk about functions with 2 variables, 3 variables, any in general. Taylor series for n-dimensional space, we'll see all these things. So once this calculus part is done, I would have gone to probability and statistics also, but I don't want to cut the sequence. So I'll teach differential equations, both ordinary and partial, okay. Differential equations, and this is both ODEs and PDEs, okay. Ordinary differential equations and partial differential equations as well, okay. Because many times I've seen people, they skip this PDEs, but if you look at papers like basically if you look at papers like civil, okay, or mechanical in fact, or even in EC sometimes, okay, or XC exclusively, there are a lot of questions from PDEs, okay. So please don't again look back PDEs. PDEs is very interesting stuff actually, okay. You have the waves, okay, waves vibrating string, or diffusion, some heat is flowing, or if you, let's say for example, if you spray perfume, how the perfume propagates, we can see the diffusion equations and all in PDEs. And I'm telling you, I'll connect all the subjects to the practical things on your technical subject, okay. It's not like I just teach this integration is this no, it works out, but at the same time I'll try to connect all the mathematical formula that we derive here to the physical things, okay. Like simple example, you all know force equal to mass into acceleration. Then this is actually a differential equation, correct? Because you have this dv by dt, okay. In fact, if you deal in 3-dimensional space, you have vectors, then this is a vector differential equation. So how to deal with all these things, okay. So we will connect. Then once differential equations is done, we'll go for vector calculus. Again, very interesting thing, and the advantage with vectors, you can solve in all the 3 directions simultaneously, okay. So this is very beautiful chapter. And then after, we'll look at complex calculus, and 7, you can see after finishing the complex calculus, but it's roughly like the finishing of the calculus, starting from the 2nd to the 6th chapter. Then we will introduce probability and statistics, which is the current day's hot cake, of course, probability and statistics. So which I would like to put some more importance on that, because ultimately every data science needs stats. So once probability and statistics is done, we come to the most powerful chapter, numerical methods. Why I'm calling it more powerful, I'll give you, okay. At introduction of each and every chapter, we'll see the applications of that particular chapter, and we'll have this numerical methods as one of the most powerful chapter, of course, okay. Then coming to the 9th, I would like to discuss a bit of transform theory, which is a bit again important for all the ECEEE guys out there. So in transform theory, we'll work with Laplace and also Fourier space, okay. Fourier transforms are very much helpful to you. So we will see how we'll calculate, not only calculating physically, we'll see what does a Fourier transform can do physically, okay. And of course, if time permits, I'm not sure pretty much, but if time permits, I'll also do fast Fourier transforms, okay, the FFTs, okay. So this is broadly the syllabus, and of course 4 years is okay. I would like to add one 10th chapter, which would make the list, sequence and series. I would like to add it for you here. So these are the topics that I'm going to cover. So I would like to roughly divide it into 10 modules, okay, so that we have linear algebra, single variables, multivariables, then differential equations, both ODEs and PDEs, vector calculus, complex calculus, 7, 8, 9 and 10 of course. So this is the syllabus that I'm going to cover in this particular module. Okay, are you all clear with what's the syllabus? So right, total lecture needed also roughly 40 maybe. Okay, yeah, we'll cover full mathematics. Okay, no issues, but please type in the chat box, is this clear to all of you? Are you all clear with what is the sequence that we are going to follow and what are the topics we are going to cover in this particular lecture? I mean in this particular module in this course. Yes, everyone. So please type in the chat box. I think all of you are busy in writing notes, correct? Writing these topics names. Don't worry, these notes will be available to you. You have the links in the description. So if you go there, you can just get the link for the notes, for the place where notes is posted. Okay, no issue at all. I want to know important chapter for civil engineering. Yeah, I have done a video what syllabus is there in which particular branch. So please refer that video on the same channel. We have the video of course. Okay. Class notes in group, I'm not sure, but we'll see. Okay, but there is a place where all this is there, so the link is in the description. Fine. So now coming into the references, of course the class notes itself will be self-sufficient for gate examination and also all other technical interviews of course, but still if you generate some interest during my teaching and if you want to refer some books, definitely I would like to suggest a couple of books for you. So one thing is B.S. Gravel, which is very well known to you. Higher engineering maths, of course you have the latest edition, 44th editions. So this you can use for problem solving and concept building. Concepts and problem solving, this is one standard textbook which you can follow. And if you want to connect things practically to your to your technical subjects, then this book, Advanced Engineering Maths by 𝐂𝐤𝐴𝐵, is fantastic book, phenomenal book actually. So this book is for practical connectivity. Practical connectivity. Okay, so this is the book for the practical connectivity. Like let's say for example, if I learn Gauss elimination method, why you need Gauss elimination method in your life? This book answers you that question. Okay, so when we develop linear systems, why Gauss elimination is one powerful technique, or what are the pitfalls in this Gauss elimination method? So all these things will of course get in this case. So for triply complex variables, yes, you do have complex variables. See, this batch is for all branches combined together, and I'm telling you, you please look at your syllabus and refer only to those chapters during the courses. Okay, and this of course linear algebra, basic calculus, I mean the single variable calculus, probability and statistics is there for every branch. Okay, now before I start the classes, I'd like to give you information on one important stuff actually, this unity. Okay, so 𝐲𝑢nity. Okay, so what is this unity? Why PW has actually developed it? I'll just give you an information. So normally during a class, you guys actually keep a lot of comments. Okay, and at times professors even they respond or they'll tell the answers, and you guys will again forget that after some time. Okay, so Unity app will actually keep a record of all your chart and all your doubts actually. Okay, like let's say for example, if I'm teaching something, if you have a doubt, then you can actually type the doubt in a particular way. Okay, so you can see here, I hope you can see, when you have a doubt in this chat box, if you want to ask me some doubt, before the actual doubt, you can just type this exclamation and doubt and then start typing your doubt. Like let's say for example, if I want to ask you what is a matrix, okay, then exclamation doubt, then you can ask what is a matrix. The advantage of asking this is this creates a track of all your doubts. Like normally if you click on this Unity app, it asks you for sign in. Okay, log in with Google account, you can see there. And if you actually log in, okay, I have logged in with mine, this is how the page comes. Okay, now during live classes we keep some polls, you guys will participate in the polls obviously. So complete your poll history or the complete year, not just this class, or the complete period gets stored in this poll accuracy. Okay, and you can see here polls attempted, classes attended, how many classes you have attended throughout the year. And let's say if I have some doubts, you can just go forward, then you can see basically what all doubts you have, what are the questions you have asked. All this track record is maintained in this Unity website. So please for this please go to the link 𝐲𝑢nity Unity, and then you can just log in with the sequence what I have taught you. It would definitely help you out. Okay, so the only thing you have to do is when you are asking a doubt, just before typing the doubt, this exclamation doubt. Similarly, if you want to make some notes, you can write exclamation note and then make some points. Those points, whatever you do during the class, will get stored in this Unity app. Even if you lose your class notes, you have a backup of the things that you have. Okay, so these are the things that I would like to proceed. Now, One thing that I would like to tell you before I start the lecture is, in my class, whenever you have any doubt, okay, you can always ask me. Okay, let's say for example, don't feel that it's a small doubt if I ask what he will think. No, nothing. Okay, you are here to learn. We all are here to learn, in fact. So if you have any doubt, please ask it immediately. I'll be the happiest one to answer. Okay, never think of anything, just ask it. Okay, during the live class you can interrupt me, no issue. And so with this introduction, I'm going to start the first lecture formally of this particular course. This is the introduction of this course. These are the reference textbooks that you can actually follow, and this is the complete syllabus that I'm going to capture in this case. Okay, and the branches, which the syllabus of all branches what I'm covering is mechanical, civil, ECE, EEE, computer science, and this XE and data science, of course. These are the things. Clear? So when math syllabus gets over, I pehle start karne do. I mean, sorry, please let me start first. Okay, fine. Schedule is already uploaded in the app, in the free batches app. In the links, if you just look at the links, you can see detailedly. Clear? Fine. So shall we start the first lecture? Are you all okay? So as I told you, the first topic that I'm going to start is linear algebra, and this is lecture number 1. So are you all ready to start this lecture? So please type in the chat box. Yes. So please type in the chat box fast. Every one of you should type in the chat box. Are you all ready to start this course? Yes or no? Fast. Ready? Complete maths or just few topics of maths? Complete maths. Okay. Yes. Okay. Fine. So the topics that I'm going to cover today is matrix and its types. As I told you, I won't expect any prerequisite from you. We'll start from 0. Okay, so we'll start from the definition of a matrix, and we will go in advanced stuff, and then we'll also see a bit of matrix algebra if time permits today. So first of all, before starting this matrix and all, why do we need matrices? Okay, why its advantages first, or what difference matrices make in our life? Can anyone tell me? Can anyone tell me why you are studying linear algebra? Because 2 days back Vanessa has made a video that linear algebra gives you 2 to 3 marks in GATE exam, so we have to study linear algebra, correct? No? What difference matrices make in your life? Anyone? I'll ask you some questions, okay? You should answer. It's okay if you don't answer, it's fine, but try to answer them. Why you are learning matrices? To solve linear equations, good. So that we can calculate the rank, okay? Maybe after calculating rank you want to do something. Matrices are useful in solving vectors, good. Yeah, we do vectors for marks and job. To calculate the rank, okay. So basically I'll just tell you one thing. First, as many of you have told, solving linear set of equations. Solving linear set of equations. And if you make a word, if you see, I'm just writing linear set of equations. I did not write the word algebraic because you can solve even differential equations sometimes. Okay, so that's why, because there are plenty concepts like quadratic form, diagonalization, all these things. They keep you a lot of the, stuff actually in solving linear set of equations actually. Okay, now not only this, we have a lot of applications in medical imaging. The reason is actually, if you take your human body, I'll just tell you one small interesting thing. This body is symmetric, okay? You know, apart from just few organs, the body generally looks symmetric, okay? So let's say if you generate a point here, you can reflect this point here about a particular axis, okay? So data science nowadays you deal with a lot of partition matrices, all these things. So data science, linear algebra techniques are very powerful actually. So if I keep talking, almost each and everything deals with matrices, okay? So linear algebra is very important thing to learn in day-to-day life, of course. And of course, solving linear equations, I just give you some idea. If I give you a equations like 2x plus 3y equal to 5, and maybe 6x plus 8y is equal to 14, something like this, if I give you, you can solve very easily. So because these are two equations in two unknowns, okay? Two equations with two unknowns, correct? But what if I give you some 100 equations with 100 unknowns? 100 equations with 100 unknowns, then ultimately your life becomes complicated, right? So to eliminate all these things, we use linear equations, of course. And now coming to the definition of a matrix. Matrix, an array of elements. An array of elements you know, basically we work with arrays in nowadays, you know, C++, Python, Java, whatever. We work a lot with arrays, so arrangements. So an array of elements in horizontal lines, called rows or vertical lines. In bracket, they are called as columns, is called a matrix. And in general, matrices are denoted with capital letters, of course. So they are denoted with capital letters in general. They are denoted by capital letters. Like for example, you see, I would like to give some classical examples, which you see, A is equal to, okay, some 2, 3, 4, 6, whatever. So here we have some elements 2, 3, 4, 6. We have arranged them in rows, in horizontal lines, which are basically rows, and also some vertical lines, which are columns, of course. Okay. Similarly, the entries inside the matrix can be alphabets. Like for example, Vinay, I'm using my name because I'm teaching. If you teach, you can use your name. Loves. Don't worry much. I'll write maths here. Okay. So I know you guys may be expecting some other name, but obviously I love maths. Okay. So that's why I've been teaching it. And then you can have a lot of things like this. Maybe 1, 2, 3. You can have etc. End of my thinking capacity. That's it. Okay. So these are the matrices, of course. We keep generating elements in rows and columns, and there are a lot of types of matrices, of course. Okay. So we will see each type, and what is the specialty of each type we will also observe. Okay. Now let me tell you one thing. This is one form of representing a matrix. But unfortunately, let's say if you have 10,000 elements in a matrix, okay, so let's say this is 3 by 3, so I'm happy to write each and every element. But let's say if I have 100 by 100 elements, okay, or 10,000 elements in a matrix, then it's not possible for me always to write all the 10,000 elements. Okay, so matrices are also defined in another form. Okay, so sorry, so will you also teach us in English medium? Not as of now, but first let us finish the English. Okay, then let's see order or size of a matrix. Looking at these definitions, please don't feel I'll teach only these definitions. We'll go to advanced things, but I want to start from 0. Okay, order or size of a matrix. So ultimately, if you take a matrix, as the name tells you, size, in every matrix there are some finite number of horizontal elements and some finite number of vertical rows also. Okay, so this number of horizontal rows and vertical rows decide the total number of operations on that matrix. Like let's say if you're adding 2 matrices, okay, then whether you can add or not, if you're adding, how many additions you have to do, these kind of, or if you have 2 matrices, if you're multiplying those 2 matrices, what should be there. Okay, so these things, the feasibility of the algebra of the matrices depends upon the size of the matrix actually. Clear? So order, if a matrix is said to be of size, or order m by n, it's read as m by n, of course. You can write this. Normally this into sign is read as m by n. If it has m rows, by this time you know what is a row, and n columns, of course. Okay, and it has n columns, of course, here. So like for example, if I say A is equal to 1, 2, 3, 4, 5, 6, for example, if I write this matrix, then ultimately you all can see this matrix has 2 horizontal rows, 2 horizontal lines, of course, this and this. So the first number always denotes the rows, and if you have checked the vertical lines, you have 3 columns. So this is 2 by 3, of course. Okay, so is it useful for diploma students? Yeah, definitely. Okay, because I'm going to start from 0. Okay, so let's see, this is 2 by 3. So if this is 2 by 3, it tells you that this matrix has 2 horizontal lines and 3 vertical lines, of course, and total number of elements in this is 2 into 3, which is 6, of course, here. Okay, so in general, a matrix of size m by n is a matrix A. Let me write here, a matrix capital A. A matrix capital A of size m by n is denoted as A m by n, of course. Okay, so it tells you that A has m rows and also n columns, of course. Okay, sorry if I believe if you teach in English, then I'll be more useful. It's okay, no issue. Okay, so once this batch gets finished, we'll plan something similar. Okay, now let's see. As I told you, now when the matrix size is simple, like 2 by 3, then totally have 6 elements inside the matrix, you'll be able to write each and every element. But let's say if the matrix size is 100 by 100 or 1000 by 1000 sometimes, okay, if you're doing finite element methods, okay, how many of you know finite element methods? Anyone of you from mechanical or civil? FEM, the popular FEM, finite element methods, or CFD, competition fluid dynamics. Do anyone of you heard these names? No? Heard but don't want to reveal, right? Because again I'll start asking some questions. No? Okay, no issue. If you don't know, it's fine. So basically there come situations in life. Okay, no issue. If you don't know, it's fine. So there come situations in life where you may have to solve some 9000 by 9000 order matrix, okay, where the total number of elements are 81 into 10 power 6. Okay, huge. We need supercomputers or very high speed computings and all to do that. Okay, so but anyway, my main intention is whenever these numbers are large, then ultimately the number of elements in this are also very large. Okay, no issues. Okay, so when this number of elements are large, how do we denote these numbers? That's what. Okay, like example, I'd like just give you an example. A is equal to, let's say if I write this matrix 2 3 4 5 6, okay, then 3 4 5 6 7 4 5 6 7 8, and maybe say this is 5 6 7 8 9. Let's say I'm stopping here. Maybe it's of size how much? 1 2 3 4 5, so 4 by 5 matrix, and it consists of 20 elements. Okay, so whenever it consists of 20 elements, let's say if I don't want to write this matrix, when I'm giving in the question, or let's say in gate examination, if I'm giving a question, I don't want to mention this complete matrix. I can also mention this matrix in another form. Look, this same matrix can be represented as A equal to Aij, where Aij is equal to I plus j for all 1 less than or equal to I less than or equal to 4, 1 less than or equal to j less than or equal to 5. If I, don't worry, I'll explain you each and every step, don't worry. Now if I write this line or if I write this matrix, both are same actually. Okay, first thing, whenever I write this element Aij, look, Aij, this first subscript which is here I, this denotes row number. This denotes row number, and whenever you have this j denotes column number. Okay, now let's see if I ask you what is the third or second column element, for example, randomly. Okay, when I say third or second column element, you guys need to calculate third row, because I told you first subscript is the row number, second column element. Okay, so it's a second column. Now I have given here Aij is equal to I plus j. Okay, means any element in the ith or jth column is equal to the sum of row number plus column number. That's how I have defined my matrix. Okay, this definition is given by me. So if I want to calculate A32, the element in the third or second column is nothing but 3 plus 2, which is equal to 5. Now you know how to identify third or second column. Come here, third row is this basically. Maybe I'll use different color. So this is the third row, this is the second column. The guy at the intersection is this is the third or second column element. The value is 5, and here this 3 plus 2 is also given as 5. Okay, so like that you can see I changes from 1 to 4. That means I can take the value, I means not me, this I. Okay, this I can take the values from 1 to 4. That means I value can be 1, I can be 2, I can be 3, I can be 4 actually. Okay, that tells you there are maximum 4 rows in this matrix. So 1 2 3 4. Okay, and j is going from 1 to 5. That means this matrix has got 5 columns, 1 2 3 4 5, and any element you can match definitely the value given by this expression and the value given by this in the matrix will be equal actually. Okay, like for example, if I want to calculate fourth or first column element, okay, so if I put I equal to 4 and j equal to 1, a41 fourth or first column element is equal to 5, and you can see this is 5 of course here. Okay, so did you all understand how we can actually represent matrices without writing the full matrix by using this? In general, if I want to specify, this aij will be given as, so in general this aij will be some function of I comma j. It can be I plus j, I power j, whatever. If I want to set the matrix, I can explain whatever I want, but I'm just telling you this matrix, in any element in the matrix can be given as some function of I comma j. Okay, now if I want to generate a 1000 by 1000 matrix, for example, let's say every element is connected in a particular way, then I can say this changes from 1 to 1000, this changes from 1 to 1000, aij is equal to that function whatever I have generated, I can give it. That's it. Clear? Did you understand? Without writing the complete matrix, just by writing one line, can you identify? And the reason why I'm teaching this is many of the gate questions come in this format. Okay, they are not interested to give you the full matrix. They'll give you this, and with this you can do what all you want. We'll see in types of matrices and all. Clear to all of you? Everyone. So please type in the chat box. Is this clear? Did you all understand this notation of writing a matrix, where you define the row and column numbers and then you define the element at random, the general element? Okay, 100% clear? Some love symbols and 100 symbols are going on. Good. Okay, guys, I'm telling you, at any point if you have any doubt, please ask me. I'll be happy to explain. Okay, please don't think it's a small doubt or big doubt or doubt. Doubt is a doubt. That's it. Okay, then let's see. Let's move on to the next case. So this is how we generally go for an example. Now shall I give you some funny exercise? Fun activity we'll do. Okay, so I just want you to figure out one thing. The sum of all the elements, of a matrix, A, where A equal to set of aij such that aij is equal to I plus j for all. Let's take a square matrix for simplicity, or maybe if you want I can complicate the question. Less than or equal to 4, maybe 4 to j less than or equal to 6. Let's say I'm taking 6 here. Okay, because if I give 5, you will ultimately add these numbers and tell me the answer, but I just want you to calculate this. Okay, is dash. Let's say if I'm giving you this question, for example, this is actually one of the gate questions, not exactly these numbers, they are given some different numbers, but this function is same, I plus j. I'm connecting a pole, integer type, ultimately answer will be integer because you can add integers. I'm giving you 120 seconds of time. I'm kind enough. So starting the poll, you can enter in the chat box. Yes, do it. Now you know how to form the matrix. Okay, so if you form the matrix and if you add the sum of all the elements, what you're going to get? That's the question. It's actually a previous gate question. Okay, I'm not teaching anything for just to tell you that I know maths. Everything that I'm teaching you is in the gate examination. Okay, come on, quick, be fast. Okay, meanwhile I'll write matrix painfully. Look, now you have to add all these numbers and tell me what is the answer. That's it. Okay, all numbers of the matrix, the summation of all the numbers of the matrix actually. Come on, quick. Think, time is running up fast. One, 1, 4, maybe, I don't know. So can we write from 1? No, because the first column element is 1 plus 1, because first column A 1 1, so 1 plus 1 2. Okay, so the first element is 2. Matrix we write in function form f of I comma j. Yes, of course. Time is up, come on, fast. Nearj 114 maybe, I don't know, I have to check. Okay, good. So let's see one thing. First of all, if people might have been little smart, many of you might have answered this question. 134. Okay, look, let's see, it's okay. 144, good. Next 124, come on. I think you guys are watching IPL a lot, huh? Fixing the targets. 114, 134, 144, good. Chalo, let's see here. I'll tell you one thing, guys. Look, if you add these numbers, okay, let's say I'm adding these numbers, how much do I get? Of course, I'll tell you a nice way to solve this question, but just I'm giving some idea. 2 plus 3, 5, 5 plus 4, 9, 9 plus 5, 14, 14 plus 6, 20, 20 plus 7, 27. This is 27. Now, if you observe little carefully, this number is 1 more than this. This number is 1 more than this. Similarly, every number is 1 more than its previous row number. Okay. If this is 27, can anyone tell me what is this sum of these values? Every number is 1 more than the previous number. So total you have 6 numbers. So can anyone tell me what comes here? Actually, these kind of questions are coming in aptitude. Okay. Last year also, 2024 also, they have given you one question. There are 2 sets of roads. On one side of the road you have numbers, house numbers like this. On other side you have house numbers like this. What is the difference and all? Okay. If this is 27, what is sum of these numbers? 33, 36, 24. I see here, if you are adding these numbers, you are getting 27. Every number in this is more than its previous row by 1. Okay, so ultimately it should be 33. Then, following the same logic, these numbers are 1 more than the previous number. So this is 39. And following the same logic, again, these numbers are 1 more than its previous numbers. So this is 45. And if you add all these things, you would get 4, 2, 4, 7, 10, 14. 144. That's it. Okay, yeah, Vasishta, you are correct. Kushaga, I think you missed some 10 here. So this is what you're getting, right? 144. Now tell me how much time it takes to solve this question. Forget about matrices. You guys need not know matrices to solve this. Tell me how much time? Silly errors. These silly mistakes are very, very costly in GATE exam. You know how much costly they are? I missed 2 times All India Rank 1 because of those silly mistakes. Okay. So anyway, I'm happy with what I have. So this 144 is the correct answer. Now tell me, 120 seconds are enough to solve this or not enough to solve this? Hi, fast here. Please tell me, these 120 seconds are good enough to solve this question or not? You might have done a lot of additions and subtractions for past 10-15 years of your life. Correct? Yes, enough? Then why you all didn't answer? Because I've given some poll time constraint. Okay, so this pressure was there in exam also. The same thing happens, but don't worry, just trust your basics, you can do it. Okay, so but anyway, this is a small question, so I have done it this way. But let's say instead of this, if I give these numbers as 2000 and 1000, things like that, I cannot keep doing this adding business. Okay, then what I have to do? Okay, so anyway, the answer is 144. So let's check it up. What we can do in general, let's say A is equal to set of Aij m by n. Let's say for example you have m by n. Aij is equal to I plus j for all 1 less than or equal to I less than or equal to m, 1 less than or equal to j less than or equal to n. Okay, so if you just look at this matrix, let's see, I'm constructing this matrix. All of you will see. First column element will be 1 plus 1 actually. Okay, will you all agree? Because first column, if you put I equal to 1 and j equal to 1, it is 1 plus 1, it gives me 2. First second column element, first third column element, this goes on first nth column element. Okay, I have this. Then coming to the next stage, second first column element, second second column element, second third column element, this third first column, third second, third column, plus n, and so on. Let's say this goes on. You have m rows in this matrix. So m plus 2, m plus 3, and so on. M plus n actually here. So let's say this is the matrix. Now you want to calculate the sum of all these numbers of the matrix, for example, let's say. Okay, then if I add first row, what all I'll get? Let's check it up. If I add all the elements in the first row, look, in the first term I have 1. In the second term also I have 1. In the third term also I have 1. So like that I have total n columns. So total I have n times of 1. Okay, so all the ones in the first place, they add up for n times of 1, because there is 1 here, 1, 1, 1, and so on. Next, coming to the story of the second term, here you have 1, here you have 2, here you have 3, so on till you have n. So the sum of all the second terms is nothing but sum of first n natural numbers. Yes or no? Will you all agree? Means it's nothing but 1 plus 2 plus 3 and so on plus n, of course. Will you all agree this? Yes or no? Please type in the chat box. Why I'm telling this is, if you are trying to plot or if you are trying to code something in C or C++, for example, or Python, okay, then we should have certain understanding in the indices, because many of you will commit mistakes with the for loops and basically for loops or if loops. Okay, in general, if it's simple, of course you'll just check the condition, but when you are doing for loops, many times people write the mistake of indices. Okay, they'll start from I equal to 1, they don't close at n. They do this kind of mistakes very frequently. So I'm just telling you this. Will you all agree with this? Please type in the chat box. Understood? 1 times of n plus sum of first n natural numbers. That's what you have. Okay, clear? Fine. Then coming to the second term, second row, here you have 2, here you have 2 again, 2 and 2's, so total n times of 2 is what you have, plus again coming to the second term, again story is same, 1, 2, 3 and so on, you'll have n. So sum of n natural numbers. If you keep doing this business, for the next row you'll get n times of 3 plus 1 plus 2 plus 3 and so on plus n actually here. Okay, now if I just extend it to my understanding, the last row gives me n times of this m plus, because there are n's actually, okay, or sorry, n number of m's plus 1 plus 2 3 and so on, n of course here. Now sum of all these elements is nothing but sum of all these elements. Okay, now let's see, sum is equal to sum of all elements. In general, this is denoted as summation I equal to 1 to m, summation j equal to 1 to n, aij. This is what you will denote actually. Okay, you will see, of course, right now just take this, I'll explain you how this comes. Okay, first you will keep j equal to 1, 2, 3 and then again keep I equal to 1, 2, 3. We'll see how these things happen, but this value is equal to, now if I add all these first terms, I can take n common from each and every term. Okay, so like for example, n of 1 plus n of 2 plus n of 3 plus and so on, n of m plus, now this term is common in each and everything and total you have m number of rows, so m times of 1 plus 2 plus 3 and so on plus n. This is what you will get. Okay, and if you simplify this, ultimately you can see n if you take common, this is 1 plus 2 plus 3 and so on plus m. This is sum of first m natural numbers, so n if I take common, I have m into m plus 1 by 2 plus m into, then this is sum of first n natural numbers, n plus 1 by 2. If I take mn by 2 common from both the terms, I have m plus n plus 2 of course. Okay, so that's the expression for the sum of the numbers. Clear? So therefore sum is equal to mn by 2 times of m plus n plus 2 of course. Clear? So this is what you have. Got it? Did you understand? Okay, this I have generated only for this function I plus j. If I have different function, then definitely elements would have been changed. Okay, did you understand how we are going to generalize the things? Yeah. So now using this formula, shall we check the previous result? Shall we check whether this is getting correct or not? Because the function is same, I plus j is only what I have given. Okay, look, I'm telling you, we have derived a formula for the general matrix. So let's examine, since this element is I plus j and this element is also I plus j, now that formula what we have derived should hold for this. Okay, now let's see, for m equal to 4, n equal to 6 because it's a 4 by 6 matrix. Sum should be equal to m n by 2 into m plus n by 2. Okay, so 4 6 are 24 by 2 into 12. So 6 144, which is this actually. Yeah, I got it. Okay, you didn't understand? Fine, no issues. Look, basically till here did you understand? Writing the matrix, did you understand? Let's go in a sequence. Okay, if you don't understand something, we'll go in a sequence and we'll start at that point where you got doubt. So let's see, this is what you have. Is this clear till here? First of all, is this clear till this point? Writing the matrix first of all. Quickly, please type a bit fast. Okay, yeah. Now if this is clear, is this clear to all of you? Till this point, is it clear? Till this point, is it clear to all of you? Till this point, is it clear to each and everyone? Yes, yes, yes. Okay, then let's see. I understand. Forget about the summation for some time. Let's say I'm adding all these things. If I add all these things, let's say this is the first, these are the first terms and these are the second terms. If I keep adding all the first terms, I can take n common from all the first terms. Okay, so if I take n common, I have 1 plus 2 plus 3 and so on plus m. Okay, so if I take n common here, I'll have 1 plus 2 plus 3 plus 4 and so on plus m. So n, if I take common, I'll have this expression, and sum of first m natural numbers is m into m plus 1 by 2. Okay, so this n into sum of first m natural numbers, m into m plus 1 by 2 plus. Now second, we have these terms. This term is common in all the steps, but total how many rows you have? It's a m by n matrix, so total you will have m times of this term. Okay, so m times of this term which you have here. So sum of first n natural numbers is n into n plus 1 by 2. So mn by 2 is common in both the terms. If you take m plus 1 plus n plus 1, m plus n plus 1 plus 1 is 2. That's what. Clear? Yes or no? Please type in the chat box. Okay, now it's clear. Everyone, Sam, Anjali, Hema, Yuva, Gauthami, sorry. Study tips for mechanical students. मुझे भी थोड़ा tips दे दो यार, मैं भी mechanical student हूँ. Okay, Hare Krishna, everyone, got it? Clear to everyone? Who all have doubts? Now it's clear. Good. So we have expressed the same expression, but because of logic, we have told the answer is 144, which matches actually. Okay. Now let's see one more thing. Summation part. Okay. Some of you have asked, please explain this summation. I'll explain. Okay. Look here. Look. Let's say I have this matrix A is equal to A11, A12, A21, A22. Let's say, for example, I'm explaining with 2 by 2 so that it is easy. So sum is equal to, you all know, A11 plus A21 plus A12 plus A22. This is what we have. Okay, A11 plus A21 plus, or maybe A11 plus A12, A21 plus A22, whatever. Then if I write this notation, sigma I equal to 1 to 2 equal to 1 to 2, sigma j equal to 1 to 2, Aij. If I write this, let's see what all we get. Okay, then it has two summations, one is for I and one is for j. Keep the I summation as it is and let us expand the j summation. Okay, j is going from 1 to 2. What does that mean? Ai1 plus Ai2. Yes or no? Will you all agree? Because I'm talking about j expansion. So if I keep I fixed, then at a particular j, if I expand this expansion, I would have ai1 because j is first replaced with 1. This is summation. So plus, then I is going from, j is going from 1 to 2. So after 1, j will take the value of 2. So this is what you will have. Okay. Now if you expand this summation, so first I equal to 1, this gives me a11 plus a12 plus, again I can go from 1 to 2 also. So therefore if you replace I with 2, actually we have a21 plus a22. Now you can see this expression and this expression both are same. Clear? Sir, inverse of matrix निकालने की सबसे short trick बता दो for 3x3 matrix. You want short trick? Okay, fine. Wait till we go for inverse. Okay, I'll definitely teach you. Okay, so see here. Did you understand how the summation works actually? How this notation works actually? Everyone. So please type in the chat box. Did you all understand how this notation works? Okay, so first it runs on the inner summation and then it takes up the outer summation. That's it. Okay. Yes, did you all get the idea? Now how to do? So writing time please. ITK, you can write running notes, and anyway these notes will be uploaded, so no issues. Fine. I'll give you one logic here. You asked me to teach short tricks, right? I can teach, I know many. Of course, you can see as this course goes on, I'll teach you many tricks. But in general, I just want to tell you one important thing. GATE exam is not about shortcuts, okay? Honestly, fact, okay? Because I have myself have secured All India 4. I know what is GATE examination. See, I'll tell you, even funnily, I see many thumbnails circulating on YouTube. This question 10 seconds mein, matlab, I'll tell in English. So solve this question in 10 seconds, solve this question in 3 seconds, 2 seconds, 1 second, and people say just by looking also you can say. Of course we do say, but I'll tell you one thing honestly. Let's say your GATE examination is set for 65 questions, okay? And these 65 questions should be solved in 180 minutes, okay? So roughly if you calculate, you have 2.7 or 2.8 minutes for each question on an average, okay? So let's say if you learn so many shortcuts and if each question can be solved in 10 seconds of, let's say 10 seconds, calculation is easy. So 65 questions should be solved in 650 seconds, which means within 11 minutes your GATE exam would have been done. Yes or no? Correct? Will you all agree with me? If I keep teaching shortcuts, I'm just telling you, I'm not criticizing or I'm not against anyone, but I'm just giving you the basic idea. If I have shortcut for solving each question, then my GATE exam would be done, or maximum in half an hour my GATE exam would have been solved, all 65 questions. Yes or no? Correct? Forget about AR1, we'll see what happens, okay? But why IITs give you 3 hours to solve this GATE paper? The reason is shortcuts. Of course, if you are very familiar with few concepts, you can apply shortcuts for those questions. But in general, GATE is not an exam of shortcuts, okay? The reason I'll tell you. If you go for a single subject, you can maybe remember some shortcuts and you can do well with the shortcuts, okay? But let's say in maths itself, let's say in linear algebra, I have taught you 5 shortcuts. Let's say, for example, okay, in linear algebra, I have taught you 5 shortcuts. Now, there are total 10 chapters. You can see in the beginning I have given the list. So this 10 chapters into 5. In maths itself, you'll have 50 shortcuts, okay? And totally, let's say you have some 10 subjects. Total, you'll have 500 shortcuts. Is it possible for any human physically to remember all the 500 shortcuts and the conditions when these shortcuts can be applied exactly and then apply in the exam? Can anyone do this? Can anyone remember all these 500 shortcuts with the conditions when they can be applied, and can they apply in the exam correctly? Is it possible? Of course, I do teach, okay, no issues, but I never ask or compels my students, if you don't know this shortcut, you will not get AR1. No need, okay? I'm happy with AR4 and I'm doing well in my life, but I don't remember many shortcuts, okay? So I'm telling you now, because see, please tell us something interesting incidents during your GATE preparation. Pakka, yeah, I'll tell. Will GATE ESC English batch come? Yeah, it's in the plan. Not possible, right? Okay. So I'll tell you some nice things in between the classes. I don't make it boring because I can tell you it's already 55 minutes since we started class. It's almost 1 hour. You can check the timer. Okay, we started sharp at 7. It's almost 7:55. Did anyone of you feel bored at any point in this? No, right? See, I'm telling you now, GATE is not about shortcuts, to be frank, okay? And of course, a lot of thumbnails and all, they circulate everywhere, but please don't believe in all the stuff. The reason is, the problem with when people say this is, see, let's say for example, if I chilled for 2 years in my life, I secured good gate rank. After securing good gate rank, if I say that I used to study 12 hours a day, people believe me, okay, because I got a rank, unfortunately, okay. So people believe this. I'm telling now, if you see, whatever the strategy a particular topper tells is valid only for that particular person, okay, because the way people study things, people understand things is different. No two individuals may understand the same thing in a same way, okay. So I'm telling you, people have different ways to learn, okay, and people follow different strategies. But unfortunately, when toppers say that this is the strategy I have followed, people, instead of learning in their own style, they forget their style and start replicating some other style, okay, which actually delays your success. Clear? So I'm telling you, please, if you can figure out this is the way that I'll understand things, you please do it your way. You will get good things in life, okay. And also I'll give you some nice useful things in maths as we progress, okay. So a lot of matrices I have taught. I just want to ask you some question. You all know, what does this give you? What does this equation give you? What does that equation give you? What does that equation give you? Line, okay. So this is a straight line. Good. Straight line, nice. Many of you have answered straight line. What does this equation give you? What does this equation give you? Circle, correct? It gives you a circle. Good. Can anyone tell me what does this equation gives you? Can anyone tell me what does that equation give you? What does this equation gives you? Any idea? No idea. Circle. Circle for previous thing or this? Nothing. It gives something, no? Why nothing? It gives something. Maybe we don't know what it gives. No? It almost gives you a square. Look, I'll just show you. Normally you can use this. Normally I keep teaching people in my classes. So Desmos graphing, you'll say. Desmos is basically a graphing calculator where you can plot lot of curves. So I'll show you maybe x square plus y square equal to 1. I hope you can see the screen, okay? It's not blurred. Okay? Forbidden 404. Good. Kids gaming. See, some kids are much interested in playing games, huh? X square plus y square is equal to 1. Okay? So you know there's a small circle which got generated here. Clear? So this is a circle, and you know ultimately this point is 1 and this point is also 0, 1 and 0, minus 1, of course. So let's check it up whether what I told you is correct or wrong. X power 2024 plus y power 2024 is equal to 1. You can see. What did you get? Can you see? See, this equation is plotted in a red color. So in a red color you have a circle. This equation is plotted in blue color. You can see there is a blue. It's a circle. It's a square which circumscribes this circle actually. Did you understand? It's a square. Can you see? Can you all see it's a square? Yes or no? How, sir? You think, okay? How this can give you a square? That's your job now. Think. Okay? I'll just tell you one thing. Circle with a square or only square? No. This is only a circle. If I delete this equation, that red color thing will go. You can see. Okay? There is no red color, only blue color. Okay? If power will be 2025, still a square? Anything beyond 2020, not only 2024, as long as this number crosses beyond 100 or 200, it gives a square. Do you want to know? I'll just, maybe I'm also not very old. Let's see. Do you want to know what does this curve gives you? Do anyone know what does this curve generates? Do you know what that curve generates? Anyone? Because I've been teaching matrices for past 1 hour, so a bit of refreshment. I have a lot of stuff like this. I'm promising we'll give you one each day. Okay, just one. In between 2 hours, somewhere I'll give you one. Circle. Why? Because this equation is square. Now you're going back. I'll give you a hint. As of now, you all are seeing the shape of this graph. Everybody now doing Desmos. आज तो पूरा दिमाग हिल गया. Parabola. No, Sagnika. No, sir. We don't know, sir. I'm giving you a hint. As of now, you all are seeing this graph, which is the shape which is generated by this equation. As of now, you're all seeing the shape which is generated by this equation. Shall I tell you? I'm very poor artist, so forgive me for some bad drawings. This is what it gives, and which you are able to see exactly on the right side of your chat box. Shall we see whether we'll get that or not? Desmos hai hamare paas. X square, the usual stuff. I'm deleting this, okay? I hope by this time you understood it's a square. Plus y minus square root of mod x power 2 is equal to 1. You can see. Okay, so that's the equation. It's plotted in green color. I have deleted all of the curves to make you understand. So this is a perfect cardioid. Okay, in polar coordinates, if you write r is equal to a times of 1 minus cos theta. Okay, so all this important stuff, nice stuff, you can enjoy. Maths is really beautiful. Okay, I'm sure if you are hating maths, that means you didn't understand maths in a correct way. Pakka. Okay, same holds for physics, chemistry, any subject in general. Fine. Did you all enjoy this? You can see this is the mathematical equation of this. Clear? So next time when you go for a people or person from mathematics department, you write I bracket x square plus y minus root of mod x whole square is equal to 1. Close the bracket and you write u. Okay? Then people understand what you're telling. Clear? Good? So let's get back into the matrices stuff again. Okay? So anyway, daily we'll spend some 5 to 6 minutes on these things. So anyway, let's see. Now we have talked about this. Then principal diagonal of a matrix, which is very much important actually. Okay, the concept of diagonalization or talking about some special types of matrices, everything comes in this. Okay, so principal diagonal, diagonal. What is the spelling of diagonal? Diagonal. Okay, principal diagonal of a matrix. Principal diagonal of a matrix. Everything fine with the graphs? Okay, so let's get back into the maths. Then the line of elements Aij, the line that passes through the elements, or else you can say that passes through the elements Aij where I is equal to j. Like for example, you take a 3 by 3 matrix to understand the job easily. You have the elements A11, A12, A13, A21, A22, A23, A31, A32, A33 of course. Okay, so let's say you have these elements. Now if you observe one thing very clearly, all these elements have the same value of I and j, correct? Like for example, you take I equal to 1 and j equal to 1, that's the element in the first column. This element also has same values of ij, and this elements also have same value of ij. Then this diagonal. Physically they won't be diagonal, but this is a hypothetical thing. So this diagonal is called the principal diagonal of the matrix. Principal diagonal of the matrix. Principal diagonal of the matrix. Now, if I is less than j, then aij is called upper diagonal element. Upper diagonal element. Like if you see this example, for example, okay, now this is the diagonal, and every element which is above this diagonal will definitely have an I value which is less than j, which means I denotes the row number and j denotes the column number. So definitely I less than j tells you that the element is sitting on the top of this upper diagonal. You can check any of these elements, definitely the row number of that element would be less than the column number. And similarly, if I is greater than j, they come to the lower diagonal elements. Okay, so if I greater than j, aij is called lower diagonal element. Lower diagonal element. And let's see sum of all the principal diagonal elements. Principal diagonal elements is called one very important word. This is very, very important, especially when we go for eigenvalues. Trace of the matrix. Trace of the matrix. Summation I equal to 1 to n aii is equal to trace of a. Normally in later stage we will see something called the initial notations. In such case you don't write the sigma. This is called the Einstein summation convention, but right now we don't focus on that. As far as our class standards, this GATE syllabus is concerned, we'll put the summation. Sigma I equal to 1 to n is nothing but sum of all the principal diagonal elements, correct? Because first if I keep a equal to 1, I equal to 1, a11, then a22 plus and so on, plus ann is called trace of a, of course. Okay, so this is called trace of a. And the beauty with this trace is, let's say if you are transforming a matrix, means let's say if for example if you are dealing with vectors, okay, and if you rotate the vectors, then if you change the system, the matrix A will take a new form, but even in such case trace will not change. Okay, so we will see all these things when we go for eigenvalues. Okay, so this is trace of A, of course. Now next definition which I would like to write is transpose of a matrix, which is very much important again. Transpose of a matrix. Okay, so transpose of a matrix. Do you all know what is transpose of a matrix? Can anyone tell me? Abdul, Kotla, Haviki, Vaisha, Yashu, Yuva, Yavashay, sorry, Harkrishnan, Mr. R, Sagnika, Sam, Anuj, any one of you. Interchange corresponding elements. About principal diagonal. Do you mean about principal diagonal? What is transpose? Can anyone tell me? Changing rows and column, interchanging. Can anyone tell me why this interchanging is important? Why you have to talk about transpose? Why interchanging is important? Can anyone tell me? Interchanging rows and columns, fine, good enough. Yeah, of course, we interchange rows with columns and columns with rows, of course. Okay, so, but can anyone tell me why this transpose business is important? Yeah, correct. Rows becomes columns, columns becomes rows. I do agree. Rotate all rows by principal axis. What is principal axis? You mean diagonal? No. Of course, maybe it looks the same, but it need not be the same many times. Okay. Transpose is required to calculate the inverse of a matrix. No, without need, I don't want transpose. Okay, without doing transpose, I can still calculate inverse of a matrix. I don't need transpose to calculate inverse of the matrix. You all might have done one thing in your BTech or maybe in your plus 12. You have, if you want to calculate inverse of a matrix, let's say A, B, C, D, E, F, 𝐂𝐻𝐼. You will take identity matrix here. By doing some operations, finally after the operations, you will see left hand side becomes identity, right hand side becomes exactly the inverse of this matrix. You might have done this. There we never talk about transpose. You remember? You have done this. You write this matrix, then you write the identity matrix here, do some row operations or column operations, whatever, and finally get the identity matrix here, and then you will get the inverse of this matrix on this side. You might have done this. Correct? Anyway, we'll see later. So let's see transpose. Why transpose is important is because few matrices, they expose, or basically in few substances, if you look at materials and all in the lattices, or basically in the chemistry, organic chemistry or inorganics, we'll see there are something called stereomers. Okay, so they exhibit certain symmetries. Not only that, there are plenty of applications, of course. So transposing means basically shifting of the things is important. Okay, transposing means, you know, it's like transforming the matrix into a particular form. So we will see why this is actually important, transpose of a matrix. So let's see, first of all, we'll see a matrix B n by m is said to be transpose of a matrix A m by n is said to be a matrix A m by n if you can better write this, AMN is equal to Aij m by n. This is equal to Bji n by m is said to be transpose of a matrix this if Aij is equal to Bji for all 1 less than or equal to I less than or equal to m, 1 less than or equal to j less than or equal to n actually. Okay, so this is the transpose. Okay, so let's see, if you look at this, then we get, like, let's say if I take A is equal to, I'll just explain you quickly, maybe by taking a 2 by 3 matrix, A11, A12, A13, okay, A21, A22, A33, sorry, A23, okay, so A23. So let's say if you have A transpose which is equal to B, okay, I forgot to write, it is denoted by A transpose. It is denoted by A with a T on the superscript or sometimes a dash on the top of A. A transpose is equal to B implies B is equal to A11, A12, A13, A21, A22, A23, correct? So A23, correct? This is what we have. Yes or no? Of course, if you transpose this matrix, this is what you will get. Yes, will you all agree with me? Please type in the chat box. If you transpose this matrix, this is what you're going to get, right? This series is also for DS and AI. Yes. Okay, we'll talk about partition matrices, their properties and all, maybe in the 3rd or 4th lectures. Okay, vector spaces, everything. So please type in the chat box. Will you all agree with me? This. Everyone, please type in the chat box. If this is A, if I write a transpose of this B, transpose of this matrix A, then this is how I'm going to get the transpose. Correct? Now, if this matrix has to be the transpose of this matrix, ultimately, this A12 and this A12 has to be same. Correct? And then this A23 has to be same because these are the same elements. Ultimately, I have just made them transpose. Now, this elements, I can write it as, if this is the size 2 by 3, ultimately this is of size 3 by 2. This matrix of size 3 by 2, I can write it as B11, B12, sorry, B21, B31, of course, then B12, B22, B32. That's what I can write, okay? Because if I want to write this matrix B in terms of B elements, then ultimately it got 3 by 2. So ultimately it should have 3 rows and 2 columns. That's what we know. Now, if you want to equate these two things, okay, because this is the general form of writing B, but this is the transpose which you got from this matrix. If these two has to be equated, you will understand something. A12 element should be same as B21. A21 should be same as B12. That means in general, if you check any of these elements, this matrix will become the transpose of this matrix if B21 is same as A12, A21 is same as B12, and so on. So that's how this Aij should be equal to Bji. If this is A12, this should contain B21 exactly at the same spot for the equality of the matrices. That's what this statement actually tells you. Clear? Yes or no? Please type in the chat box. Everyone. So please type in the chat box. Clear? Did you understand this initial notation of representation of transpose? Got it? Okay. Now let's understand some things again. Properties of a transpose, which is a bit important. Properties of transpose. Properties of transpose. Okay. So let's see. First, if you have two matrices A plus B whole transpose can be written as A transpose plus B transpose. Okay, so you can just split it, because ultimately if you all know matrix addition, I guess. Is there someone who don't know matrix addition? If you don't know, I'll explain, no issues. Is it clear? Do you all know how to do matrix addition? If two matrices are given to you of same size, of course, if they are not of same size, you cannot add them. But if two matrices are of same size, do you all know how to add them? Should we learn that? Yeah, maybe, because many times questions in GATE examination, if you open PYQs, you'll see they'll give you in the initial form. Okay, IJ notations. Okay, just a minute here, I'll have some water. So do you all know how to add two matrices? If two matrices are given, then just adding the two matrices. Do you know how to do that? Please type in the chat box. Okay, adding corresponding elements, of course. Okay, now let's see. So if you add two matrices and if you take transpose, that's same as taking transpose and adding them up. Then if you have K times A whole transpose, where K is a scalar, K is a scalar. For scalar you cannot do a transpose, of course, and this becomes K times A transpose. Okay, and the third axiom you all know. If you do transpose even number of times, you will get the same matrix. If you do odd number of times, you will have the transpose of that matrix. Okay, so this is what you have. Now let's look at some types of matrices first. Types of matrices. Okay, so okay, we had some slide here. Fine, we'll put it somewhat forward. Okay, so see here, types of matrices. So put a heading in your notebook. We'll see types of matrices. Okay, so the first kind that we look at is square matrix, of course. Very simple definitions. Square matrix. So ultimately, what is a square matrix? Can anyone tell me? What is a square matrix? Of course. What is a square matrix? All of you, quick, a bit fast. What is a square matrix? Properties of trace of matrix. We'll see. Okay, because I just want to teach you multiplication of matrices. After that, I'll teach you properties of trace. Okay, because then it's more useful. Where diagonal exists and number of rows equal to number of columns. Same rows and columns. Okay, of course. So you know a matrix Aij m by n is said to be a square matrix a square matrix if you know m equal to n, of course. Number of rows equal to number of columns, so ultimately it has a diagonal that exists. Okay, so example, if you want, I can just give you maybe something like a is equal to a, b, c, d, whatever. Okay, you know, basically number of rows and number of columns should be equal. Yeah, m equal to n, of course. Okay, then clear, I equal to j. It's not I equal to j, m should be equal to n, of course. Okay, because I equal to j just gives you one element on the principal diagonal. That's it. Okay, then let's see the second form is upper triangular matrix. Can anyone tell me what is an upper triangular matrix? Any idea to any one of you? Shreshth, Bhattacharya, Anjali, Sam, Thomas, Sridhar, Kotla, Manoj Kumar, Lokesh, Vasistha, Abdul, Yuvashri, Kushaga, every one of you. Lower side 0. Ij equal to 0 for all I greater than j. Fantastic. Yeah. So let's see. A matrix, I'll just write the definition first. A is said to be an upper triangular matrix if all the lower diagonal elements are zeros. If all the lower diagonal elements are zeros. Okay, or you can also write this. I've told you what is a lower diagonal element previously. A matrix A equal to Aij is for all 1 less than or equal to I comma j less than or equal to n, because if it's not square matrix you cannot define what is a diagonal. Okay, so that's why. So LU decomposition method, please. Okay, yeah, we have just started matrices. Okay, we'll go through a lot of things. We'll see system of equations. I'll teach you Gauss elimination, LU decomposition, Gauss Jordan, everything. Okay, even Gauss Seidel. Okay, no issues. So look here. So a matrix capital A is equal to Aij for all 1 less than or equal to I comma j less than or equal to n is said to be an upper triangular matrix So previously I have told you, when does an element fall under the lower diagonal or below the diagonal? You can see if I have shown it, right? Just a minute, somewhere I have shown. So here you can see this denotes column number, this denotes row number, of course, and you can see if I is less than j, this is called upper diagonal element, and if I is greater than j, then the element is lower diagonal element. And to call this matrix an upper triangular matrix, I am telling all the lower diagonal elements are 0 if Aij is equal to 0 for all I greater than j. Okay, so example, you can see A is equal to 2, 3, 0, 4, 2 or 0, 7, 8, 0, 4 or 0, 0, 0. You can have something like this. Look here, if you observe something, this is the diagonal and this is the lower triangular elements, and all lower triangular elements okay, so you can see all these elements are zeros. When I am defining this statement, I never bothered about these elements or these elements. Only thing that should happen is all my lower diagonal elements should be zeros. It is zeros. It's not mandatory that these elements are non-zeros or those numbers are not negative. You can do it anything. Okay, so lower is 0. Yeah, basically lower is 0. Okay, then if you look at lower triangular matrix, then lower triangular matrix. Okay, so let's see. Now by this time you can understand a matrix A is equal to Aij n by n for all 1 less than or equal to I comma less than or I comma j less than or equal to n is said to be a lower triangular matrix if 𝐴𝐼𝐽 is equal to 0 for all I less than j. Okay, that's it. Means all the upper elements are zeros. Okay, so this tells you this statement which is here. This statement tells you all upper diagonal elements are 0. All upper diagonal elements are 0, of course. Got it? Clear? And if you want to look at an example, if you take A11, A1, A22, A23, then all these elements in the upper triangle should be 0, and you have this is what you have here. Okay, sorry, this is 3, A 3, this is what you have. Okay, and clearly in this case all the upper diagonal elements are zeros. So this is the upper triangle. Okay, and you guys want to make all aij is equal to 0 for I greater than, less than j, of course. Okay, so this is what you have. So I have a request. In these days, these are various new types of questions are coming in GATE from numerical methods. Would you take care of this? Why not? We'll definitely take. Okay, so this is a lower triangular matrix. Now there comes one special case which is diagonal matrix. Okay, and really the use of diagonal matrix is like unlimited. Okay, frankly speaking, many times even though the matrix is containing all the elements, we intentionally make it diagonalized. Okay, that's what we call the diagonalization process. We will see diagonalization of matrices maybe in the last lecture of this module, linear algebra. So I'm telling you, making a matrix into a diagonal form could help you a lot actually in solving solutions. Okay, we will see when we are looking at the concepts of diagonalizations. Okay, so upper and lower triangular matrices are only for square matrix or not? Yes, because for other matrices you cannot define what's a diagonal, that's why. Okay, so let's see diagonal matrix. Diagonal matrix. Okay, then let's see a matrix A equal to aij for all 1 less than or equal to I comma j less than or equal to n is said to be a diagonal matrix if aij is equal to 0 for all I not equal to j. That's it. Okay, which means, so can you please tell where this matrix is used really in engineering applications like in FEM and CFD, how matrix is used? Okay, please take this. Normally in FEM you calculate stiffness matrices. Okay, so normally you have this, many of you might have studied your +1, you might have studied F equal to Kx. Okay, so that's in one direction. So let's say if material can actually is elastic in different directions, we apply the traction is equal to some k times the displacement. Okay, so there k is actually a stiffness matrix. Similarly, when you're coming for CFDs and all, we look at sparse systems, okay, which are a bit advanced, which is not in the GATE syllabus scope, of course, to any branch in fact. So to solve the sparse systems and all, we go for diagonalizations. Okay, and not only sparse systems, normally if you go for transformations of coordinates. Okay, so let's say if you have we'll see much more detail in vector calculus. If you resolve a vector in xy coordinate system and in polar system, how the components of velocity are connected, okay, how the components of velocity in Cartesian is connected to the components of velocity in polar, this connection is again given by matrices. So there are plenty of advantages when you deal with matrices. We'll see in each way. Okay, so now we can see what is a diagonal matrix. Of course, only should have diagonal elements. Okay, so lambda 1 0 0 maybe 0, lambda 2 0 0 0, lambda 3. Let's say these are 3 elements. Okay, then this is what you call it diagonal matrix. If these are the diagonal matrices, then definitely upper diagonal element should be 0 and lower diagonal element should also be 0. Correct? So if upper diagonal is 0, then ultimately aij is equal to 0 if I greater than j, this actually implies aij is equal to 0 for all I not equal to j, correct? Because it's telling you if I is greater than j or if I is less than j, then still these elements are 0. That means in a single equation you can write whenever I is not equal to j, these elements are of course 0. Good. Can diagonal elements also be 0? Why not? See, I'm never putting a restriction on the diagonal elements. I'm telling you these elements are 0s if I is not equal to j. I'm not talking anything about the elements when I equal to j. Got it? They can be 0s, they can be non-zeros. It depends. Okay. Abdul, clear? See, in life, having clarity is very important. Okay. See, basically I'm telling you, let's say if you're working in office tomorrow, okay. Let's say for example, if I'm your boss and if I tell you, okay, Abdul, you go and check whether Vasistha has come today or not. Then it doesn't mean that you should go and call Vasistha to me. Your boss told, did he come or not? You should just see and say, yeah, he came. Because, but some people what they do, whenever boss says whether did he come, then immediately they go there and call that boss is calling you. But this is not the way. Okay. So same thing. When I'm telling about non-diagonal elements, please be focused with the non-diagonal elements. That's it. Okay. Anything can happen to the diagonal elements, and depending upon anything can happen to diagonal elements, we will do some analysis again. Okay. So that we will see again when we go for calculating determinants. Okay. Clear? Voice of Satish. Thank you. So this is diagonal element, diagonal matrix, of course. 5, 4. Okay. 5. Scalar matrix. Scalar matrix. So a matrix A I comma j less than or equal to n is said to be a scalar matrix. A scalar matrix if do anyone know? So how long this lecture will be? Till 9 PM. Okay, 27 minutes more. Clear? Because I understand keeping all this stuff on a same day can actually make you irritated. So we will deal in a stepwise way. No issues. So can we say that diagonal matrix is a subset of upper triangular? Yeah, definitely we can say that. I'm actually in paid batch, but want to learn maths from you after learning your demo recorded lectures. Thank you. Yeah, thank you. Hi Krishnan Rajmohan. What we are talking? Yeah. So scalar matrix. Aij is equal to k for all I equal to j. Lokesh, you are my student, right? If I'm not wrong, because only you are the one who is telling all the answers. Are you my student, Lokesh? Just by curiosity, I'm asking. Somewhere you might have learned maths from me, right? Because you are the one only who is typing all the exact answers. Yes, I know. Otherwise, who else tells that? Good. Anyway, I'm just kidding. Anyone can tell that. Look, if Aij equal to k for all I equal to j, 0 for I not equal to j, of course. Okay, that means it's special case of diagonal matrix where all the diagonal elements are equal. That's it. Okay, so k is a scalar in general. Example, A is equal to k 0 0 0 k 0 0 0 k, of course, here. Okay, so this is what you get. Now you can see if k equal to 1, then A is called, you know, if you put k equal to 1, then what is A? Let's say if the constant value is 1, then what is this matrix? If k value is equal to 1, then what is the matrix? It's a identity matrix, right? Yeah, of course, unit matrix then. So it's a identity matrix, or it's basically called unit matrix. So this is identity matrix. And if k equal to 0, do anyone know the name for this? If k equal to 0, then it is correct, Satya. P, it's unit matrix. Basically, if k equal to 0, it's called a null matrix, right? Null, or it's also called 0 matrix. 0 matrix. Okay, so this basically is scalar matrix. Now let's see, let's go to the definitions of some other matrices. Symmetric matrix. symmetric matrix. A matrix A equal to Aij for all 1 less than or equal to I comma j less than or equal to n is said to be a symmetric matrix if when do you call the matrix as symmetric matrix? Transpose of a matrix is itself fine. Okay, 2, I agree. A equal to A transpose. Okay. What can you say about Aij? Like we are telling everything in terms of Aij, no? So what can you say in terms of Aij? You can think and tell. You can say. Yes, exactly, Satya. Aij should be equal to Aji because it should equal to its own transpose, correct? So Aij equal to Aji, right? Aij equal to Aji, I not equal to j. If I equal to j also, then Aii is equal to Aii, you know, correct? Yes, Aji mega, very good, correct. Abdul, Satya, everyone. So Aji should be equal to Aji, and if you just quote an example, we have A is equal to A11, A12, A13 for example. Again A21, let's say for examplify it. Okay, A21, A22, A23, A31, A32 and A33 for example. Okay, then ultimately if this matrix has to be a symmetric matrix, then this element should be equal to A12, correct? Because when you do transpose, this element in the first or second column comes to the element in the second or first column. So that means when this element comes to this place, and if A and A transpose has to be same, then this element and this element should be same. A12 should be same as A21. Similarly, this A13 should be same as A31. This is A13, and ultimately this A23 should be same as this guy here. So that's what in general Aij should be same as Aji, of course. Clear to all? Okay. Clear, guys? Is this clear to all of you? Yes or no? Please type in the chat box. Chat box. Okay. Going good? Understanding the things? Only last 20 minutes. So please type in the chat box. Are you all able to understand the things? Each and every point in detail. Okay. So let's get into skew symmetric matrix. Skew symmetric matrix. The matrix is symmetric but with a skew of negativeness. That's it. Okay. So let's see. In this skew symmetric matrix, Aij equal to minus Aji. Good. Nice. Same as symmetric matrix, minus will be added. Sir, can you please explain this for all? Then that inequality being written, please. Sorry, didn't get you. Sir, can you please explain this for all? Then that inequality being written. Inequality. Where did I write inequality? I'm not getting. Did I write any inequality anywhere? This one. This inequality. 1 less than or equal to I comma j less than or equal to n. That's it. Okay. It tells you, like, let's say if it tells you 2 less than or equal to x less than or equal to 4, then you'll say x can be 2, 3, 4. Correct? Or basically you can say x lies in between 2 and 4. Okay, but here this I comma j are only integers because row and column numbers can be only integers. So that means this x can take 2, 3, 4. That's what I'm writing. Okay, clear? Nothing bigger than that. Okay, so let's see. Yeah, good. Aij is equal to minus Aji. Good, of course. Now people are getting. Okay, initially when I started the class, when I'm telling initial notation, many of you felt difficulty, but now you guys are suggesting me to write Aij equal to minus Aji for symmetric, skew symmetric. Good. So yeah, of course, too. A matrix capital A is equal to aij for all 1 less than or equal to I comma j less than or equal to n, is said to be skew symmetric, is said to be, just a minute, okay, is said to be skew symmetric if aij is equal to minus aji actually. Okay, so aij is equal to minus aji. So ultimately, you know, this statement, of course, which many of you are familiar, this actually tells you that A is equal to minus A transpose, or some people they like to say A plus A transpose is equal to 0. Both are correct. Now let's observe something, few points about this. Principal diagonal elements, principal diagonal elements of a skew symmetric matrix are, can anyone tell me what would be the value of a principal diagonal element of a skew symmetric matrix? Also aij equal to 0 for I equal to j for skew symmetric. That's what I just want to see. But just tell me, if you look at the principal diagonal element of a skew symmetric matrix, can anyone tell me what would be the value of that element if A transpose has to be equal to minus A? Come on, all of you. Quick, faster. Zero. Yeah, 0. Okay, it is 0. Zeros. I look, many of you are thinking, just tell me one way. When you transpose a matrix, will the principal diagonal elements change their position? Let's say I have a matrix, okay? Now you are transposing that matrix. If you transpose that matrix, then will you or will the principal diagonal elements, will they change their positions? If you transpose a matrix, will the principal diagonal elements change their positions? No, correct? They are not changing. So let's say if one of the principal diagonal element is x. Now when you are transposing that, the x remains as x in the same position, okay? Then if you are telling x is equal to minus x, okay, because this minus sign is there, okay, and whenever the element lies on the principal diagonal, it don't changes its position. That means a number should be negative of itself if the element is on the principal diagonal element, correct? If the element is on the principal diagonal element, that means the element on the principal diagonal should be equal to negative of itself. Which number will be equal to negative of itself? Tell me. Which number will be equal to negative of its own? Which number will be equal to negative of its own? Which number will be negative of its own? Don't know. X equal to minus x है तो x का value, what is the value of x? I should ask in a mathematical way, no? X is equal to minus x, then what is x? Then people are happy. Put that minus x on this side and 2x equal to 0. Since 2 is not equal to 0, so x should be 0. That's it, right? 0. So, you know, since aij equal to minus aji, for I equal to j, what you can get? aii is equal to minus aii. This implies 2 times of aii is equal to 0. So aii is equal to 0. That's it. Okay. So this tells you. Okay. So every principal diagonal element on a skew symmetric matrix has to be 0 undoubtedly. And so example, if I just give you an example. 0, 0, 0, you fill with zeros. If you keep a12 here, it should be minus a12. Then if you keep a13 here, it should be minus a13. Then maybe you can keep a32 minus a32. That's it. Okay. Also, I just want to ask you one question. Before I ask you this question, I would like to solve a question. Okay. I want to solve a question. Come on, solve this question. I'm connecting pole. Of course, for previous answer, the answer is 144. None of you have answered, fortunately, good. Now for this pole, I'm giving pole of, say 90 seconds. Start. See, for matrix M, Mij, for all, this is small I, of course, okay. So I comma j equal to 1, 2, 3, 4. So I less 1 less, this is same notation as 1 less than or equal to I comma j less than or equal to 4. The diagonal elements are all 0 and Mij equal to minus Mji, of course. The minimum number of elements required to fully specify the matrix is. So you can actually type the answer in the chat box, that automatically comes in the poll. Okay. Come on, quick. So how many elements do you need to completely specify the matrix? In that matrix you have 16 elements, okay, because it's 4 by 4. So how many elements you have to specify fully if you want to know the complete matrix? This is actually 1 year gate question. Solve. See, if your answer is 0, please type A in the chat box. If your answer is 6, please type B. If your answer is 12, please type C, and 16 D. Kushaka Pandey 6, okay, maybe, okay. The correct answer is 6, of course, okay, 100%. Patakti Atma only has done it, fine, okay. Maybe few responses it has not taken, good. See, it's not 12, basically, I'll tell you why. Mij is equal to minus Mji, and you know this I comma j are going from 1 to 4. M can be written as M11, M12, I'm just writing so that you can understand the things. M21, M22, M23. This is previous year gate question, okay. You see, this notation is given, that's why I'm teaching you this. So look, 4, 4, okay. So see here, now whenever I say this Mij is equal to minus Mji, immediately you can figure out one thing, that this is a skew symmetric matrix, of course. Skew symmetric matrix, correct. Now in general, if I want to know anything about 4 by 4 matrix, I should know all the 16 elements, okay. I should know what is M11, M12, similarly till M44 I should know each and everything. But since this is skew symmetric, I need not tell you what are the diagonal elements, yes or no. Let's understand in a step by step way. Look, since it is skew symmetric, I need not tell you what are the diagonal elements. You know by default they are zeros. I need not tell you this information, correct. Will you all agree? If I say, if in this matrix, if this is skew symmetric, then I need not give you information about the diagonal elements because you know that it is 0, correct. Yes or no, yeah, please type in the chat box. You guys can just simply sit and type it, so please type at least. Yeah, yes. Now let's say if I give you information about this element, then do I need to give you information about this element? If I give you M12, should I again give you what is M21 value? If I give you data about M12, then do I need to give you about M21? Is it necessary for you to give M21 again if I give M12 already? Will you cover from 𝐂𝐸 point of view? Yeah, I'll cover Legend of PUBG. Good. That's why I've added sequence and series at the last. Okay. So basically what I'm telling is, if I give this element, I need not talk about this, because if I give m12, you can by default write m21, because if you put m21 equal to, if you put I equal to and j equal to 1, m21 is nothing but minus m12. So if I give this, then I need not give this, okay, because this is just the negative sign of this element. Similarly, if I give this, I need not give this. If I give this, I need not give this. Similarly, giving m23 need not give these elements. If I give m34, I need not give. Means out of this remaining 12 elements, if I refer any 6, okay, simple negative of this this thing, correct? So if you see, out of this total 16 elements, these 4 I need not mention, they are zeros by default. Now out of remaining 12, if I specify this either upper triangular 6 or lower triangular 6, then I can get information about the full matrix, okay. That's why it is 6. There are 6 independent elements. And it's a previous gate question. Answer is B. Okay, so there are 6 independent elements in that matrix of total 16 elements. If I can specify those 6 elements, you can 100% tell all the 16 the information about all the 16. So what about the diagonal 1 0? Won't that be counted? No, because if I tell you the matrix is skew symmetric, I need not tell you the diagonal is 0. You know that the diagonal is 0 by default. Okay, so diagonal is not counted because I need not tell you that diagonal is 0. You can identify it by yourself if I tell you the matrix is a skew symmetric matrix. Okay, because of this, what I have taught you here, you know, I have taught something here. So where is it? Yeah, here. Okay, so these 2 steps I have taught you. Okay, we'll solve one more question which could give some important things. For an n by n array, which is n by n matrix, of course, V is defined as follows: Vij is equal to I minus j for all I comma j, for all I comma j such that 1 less than or equal to I comma j less than or equal to n. Then the sum of elements of the array V is dash, which is nothing but the same question. Vij is equal to I minus j for all 1 less than or equal to I comma j less than or equal to n. Then sum of all elements of V of V. Can anyone tell me? If the element in, see, for example, if I have defined I plus j, okay, you have seen how things come up. If it is I minus j, then what would be sum of all the elements of the matrix? Okay, I'm again connecting pole, so single choice. I'm giving maybe 90 seconds you take. Okay, fine, no issue. Think. See, if you want to enter 0, you enter A. Okay, if you want to enter n, you enter B. This is n plus 1, then you enter C. This time many of you are failing to answer. Okay, good. Yay. Oh, so many are typing yay. Maybe. Maybe this is the last question that we'll solve today, because only 5 minutes is left. Corresponding elements will cancel out and diagonal will be 0. Good logic, of course. See, once you participate at the polls, as I have told you, you can check it in Unity app, okay, or basically in the Unity website. So there you can check. Okay, so yeah, the correct answer is 0, of course. Oh, there's a big list. Nice. Abdul, Vasista. Oh, it takes only top 5, I guess. I'm not sure, but yeah, hi Krishna. Good. So let's see. First of all, I want to just tell you one thing. Vij is equal to I minus j, correct? This implies if I talk about Vji, this should be j minus I. Yes or no? Correct? Because if it is ij, it is I minus j. So if it is ji, it should be j minus I, of course. Okay. So if you take a minus sign, it becomes I minus j, and I minus j can be replaced with ij. So Vji is equal to minus Vij. This tells you the matrix is skew-symmetric. Matrix is skew-symmetric. Okay, matrix is skew-symmetric, and you know, sum of all the elements of a skew-symmetric matrix is 0. A is the correct answer. Okay, so this can be done even easily. Look, for example, if I look here, okay, these three elements do not contribute for any summation because they are zeros itself. Some of these two would be 0, some of these two would be 0, some of these two would also be 0. Okay, so for every element there will be a contradicting element with a minus sign, so some of those two elements would be 0. Like for example, you see, I'll just give as a point here, you can write sum of all the elements of a skew-symmetric matrix are sum, okay, is 0. Like for example, you can see, you know one thing, that sum of summation I equal to 1 to n, summation j equal to 1 to n aij, this is what you have. Okay, so this is summation, of course. Just let me tell you one thing, let's say this is equal to k, for example. Okay, then can I write the same summation as, if I interchange I and j, of course, this can be written as k is equal to summation j equal to 1 to n, summation I equal to 1 to n aji. Okay, but this aji can be written as which is equal to minus k, of course, because these summations can be flapped. So k equal to minus k. That's it. Okay, clear? So let's say initially you have to take the sum as k, then you can interchange these two, of course, summations and aji. So aji can be replaced with minus aij. So if you take this minus and again replace this, this is minus k. So k equal to 0. Clear? Not clear? For how many of you it is not clear, tell honestly. I'll explain step by step. No issue. For how many of you it is not clear, please say honestly. Okay, be honest. I am honest to you, so you too be honest to me. That's it. Not clear? Good. I'll explain you. Okay. Good. Okay, yeah, I'll explain again, no issue. See here, sum of all the elements. See, first of all, you know, aij is equal to minus aji. This implies aij plus aji is equal to 0. This is what you know. Okay, aij plus aji is equal to 0. Sir, any upcoming Hinglish batch? Yeah, there are a lot of coming up every I think every month some orientation sessions goes on, and you can look at Wallah mechanical Hinglish channel, of course the main channel of mechanical EC, TEEE, these kind of channels were there, so you can look at there. You definitely will be provided with the updates. Okay, then let's see. And once again, I am telling you, this is my Telegram group, so if some of you are interested, you can join there if you want to get in touch with me. And if you want to know all the updates about the English channel, then definitely please go for this group. So I have clearly kept, this is Wallah English and this is Telegram channel of mine. Okay, so anyway, let's move forward to this. After this we'll close this lecture today. So let's say you have, so let's say sum of all the elements, all the elements summation I equal to 1 to n summation j equal to 1 to n aij. This is what you will get. I have told you already. Okay, and I have told you how this summation could actually give you the complete sum of all the elements. I have explained you. Now let's see this expression. If you just expand, for example, you will have sum of all the elements a11 plus a12 plus a21, sorry, a13 and so on plus a1n plus a21 plus a22 plus a23 plus and so on a2n plus a31 plus a32 plus a33 plus and so on a3n plus, if this goes on, you'll have an1, an2, an3. Okay, will you all agree? Class will be daily, okay, daily from 7 p.m. to 9 p.m. Of course, we'll go to the details just before I close. So this is what we have, correct? So this is going to be the sum of all the elements of that matrix. Yes? Yes or no? Please type in the chat box. This is going to be the sum of all the elements of the matrix, which is of course the same as this. Okay. Now what I am telling is, these elements are zeros by default, a2 to 0, because this is skew symmetric. Now since you know aij plus aj1 equal to 0, this tells you a11 plus a21, sorry, a12 plus a21, this is equal to 0. Similarly, this element will cancel this. This element will cancel this, because a23 is equal to minus a32. When you add, these two elements gets cancelled. Similarly, a1n and an1, a2n, an2, because an2 will be minus of this number. When you add a2n to this, you will get 0. This, and finally everything gets cancelled and you will get 0 actually. Okay, this is what I have done in a slight short way. Okay, but anyway, so in EC math syllabus, do we have transform theory? It's not included in IISc syllabus. It's actually there because you know, basically if you want to work at your control systems, you need Laplace transforms. Okay, and if you are working with signals and systems, you will work with Fourier transforms. So ultimately, indirectly, it may not be mentioned in the math syllabus, expecting maybe signals and systems faculty to teach that, but you have to have good knowledge of Laplace and Fourier transforms. Okay, so have you showed the solution in symbolic manner earlier? Basically what I have told is, I have assumed this total sum to be k. Okay, then I have changed the indices. So this becomes a21 and this becomes a12. This becomes a31 and this becomes a13. So this total summation is also equal to k. Okay, but when I have changed the signs, I can replace a12 with minus a21, a31 with minus a13. So like that, I can take one minus sign common from all these numbers. Okay, I'll just tell you. So for example, if I take a 2 by 2, okay, you will understand maybe easily. So let's say this is a21, for example. Initially what I have taken is summation k is equal to a12 plus a21, of course. Okay, now this, since I have changed the indices j and I have interchanged, I can write this as a21 plus a12 because these two are same. But actually I can replace this a21 as minus a12 minus a21. If I take minus sign common, I'll have a12 plus a21, and this term can be replaced again with this k, so minus k. So k equal to minus k, so k has to be 0. This is what I have done in a shortcut. That's it. Did you understand? First thing I have done is I have interchanged the notations, and then I have used this minus sign property, so to show k equal to minus k, so ultimately k has to be 0. That's it. That's what I have done. Okay, but I think people are familiar with this and happy with this. Okay, no issue. Okay, did you understand this? Is this clear what I have done? I have taken this sum as k. Of course, diagonal elements are anyhow 0. I have neglected them. Or even if you take aii will become 0, of course. So first I have flipped the indices. So a21 plus a12. This summation and this summation will remain same. But here I have used the property of skew symmetric. So I got negative of this k actually. So k equal to minus k. So k is 0. That's it. Okay, a bit of smarter, but actually, you know, when we are doing programming, especially this kind of stuff helps you a lot. Fine. So anyway, we'll stop here for today, because I know for some of you who have learned this for the first time, it would be slightly hectic. So I'll stop here for today. So let us have a quick review. So basically, these are the channels. If you wish, you can join in these two, so you can get some understanding. Then this is the syllabus that we are going to cover. We started with linear algebra. Okay, then these are the books. Of course, this is for conceptual and problems, and this is for technical connectivity, practical connectivity of the subject. And so we have started with matrix definition. Then we have went to a lot of things, fortunately, and we have talked about types of matrices, upper triangular, lower triangular. Then we talked about some graphs to make you understand a few nice things. Then properties of transpose and scalar matrix, principal diagonals. Okay, then this summation. Then we have solved some 2 problems. Of course, we'll solve more in the upcoming classes. So tomorrow's class will be mainly dedicated to matrix algebra. Okay, we'll see properties of addition, subtractions, multiplications. Again, in multiplications we have some nice things to understand. So we will see all these things in tomorrow's session, and then we will progress slowly. Okay, so again, I would like to remember you, please go for this link, okay, unity.pw.live, so that you can track all your record at one place. Okay, even if you forget them at later stage, you can still have the resource in this. And whenever you're typing doubts, I suggest you please type this exclamation doubt and then type doubts. And similarly, if you want to make a note, please type exclamation note and then type whatever you want to save in your catalog. And of course, every day we'll be starting at 7 p.m. I hope I didn't bore you much today. So daily 7 p.m. Monday to Saturday, and this fellow is me. And yeah, in English only I'll be teaching in this complete batch. Okay, so in English we'll teach, and classes will be from Monday to Saturday 7 p.m. and as I told you, this will be a complete comprehensive course. Okay, I'll deal each and every point, and if you have doubts you can always ask me. Okay, and at some point in the daytime, if you have doubt, you can post it in the Telegram group. People will be happy to answer that. Okay, and yeah, I think then that's it from my side. You have anything to say? Fine then. Did you all understand each and every point? Shashwata Bhattacharya Harikrishnan, digital battlegrounds. Okay, nice name, huh? Like the lecture? Good pedagogy. Great. Okay, so it's not the first lecture since I mean, I've been teaching this story for past 7 plus years, so no issues. I'll be teaching you in a good way. You can trust me, and I hope that's what happened in the first lecture. Okay, so tomorrow sharp 7 p.m. you come. We'll play with some matrices tomorrow also, and then slowly we'll go into the depths, okay, of determinant, system of equations, rank, and then after we'll speak about system of equations, eigenvalues, eigenvectors. Physically, geometrically, we'll see what is eigenvalue, what is eigenvector. We'll talk about all these things. Okay, so fine. If you have any queries, you can ask me, or else signing off. Okay, I hope all of you like the session. Liking is again, I always say, not hitting the like button, but the content what I've delivered. Okay, so thank you all. We'll meet tomorrow at 7 p.m. for matrix algebra. Thank you. Okay, signing off. Bye. Good night. Take care.